So right here you have a lesson, but we're not going to do the whole thing. We're just going to focus in on the parts of the lesson that are necessary for the quadratic formula, okay? So we definitely need to know this first part. We need to know how to make a perfect square number list. How do we do that? Let's all follow along right now on your blue paper. There's your first perfect square number, the number 1. Then the next one is 4. The next one's 9. The next one's 16. If you're wondering, how am I getting these numbers? It's called the perfect square number list because you take a number and square it. The number 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. And of course, the list goes on forever and ever and ever. Now, the reason why I want you guys to write down this list is so you could become familiar with these perfect square numbers, and it'll help you when they ask you to simplify square roots. So if we read this fact, the square root of a perfect square number is a perfect answer. And the square root of any of these numbers up here is a nice, beautiful answer. The square root of 16, that's up there, that's 4. The square root of 81, that's up there, that's 9. The square root of 121, that's up there, that's 11. The square root of any of these guys is nice and beautiful, right? What's the square root of 25? 5. What's the square root of 81? 9. What's the square root of 144? 12. Square root of 4? 2, right? But so any of those numbers on that list is beautiful when you do the square root of it. But if I say, what's the square root of 20? Well, 20 is not on that list. And see, the thing is this, we want a perfect square number inside a radical, okay? So when we don't have a perfect square number inside a radical, we're going to use this rule right here that allows us to split the square root to each of the terms that we're multiplying, okay? And we're going to come to this fact down here. It says, if you do not have a perfect square number, break it down with multiplication to get a perfect square number, okay? We would love this 20 to be a perfect square number like 25. The answer would be 5, but it's 20. So I need to rewrite it with multiplication to get a perfect square number. 20 is not a perfect square number. I need to rewrite it with multiplication to get a perfect square number. So what times what is 20 where I could use one of these numbers? 4 times 5, exactly. So let's go, instead of 20, let's go 4 times 5. And we're going to take that square root that was on the 20 and we're going to split it to each of these. So what is the square root of 4? 2. That was the whole purpose of rewriting it to get a perfect square number. And the square root of 5, it just stays the square root of 5. And that's it. That's your answer. For real? For real. Now, this, guys, this right here, you see, any square root of a non-perfect square number gives you a crazy decimal as an answer. If you were to get your cell phone calculator, turn it to the side so it'll be on scientific mode, and you do the square root of 20, it'll be a crazy decimal answer that continues forever and ever and ever. Right? It'll take up your whole screen. This is the same crazy decimal forever answer, but it looks a little bit nicer. This is what we call simplifying. The square root of 20 is 2 square root of 5. So again,
you want it in the pretty way.
You want it simplified, yeah. And if you have a perfect square number, it's really easy. What's the square root of 49? 7, done, right? But if it's not a perfect square number, like let's say the square root of 32, okay? You want to break that down with multiplication to get a perfect square number. So what times what is 32 where we could have a perfect square number? 4 times 8, right? Now, I heard you guys say 8 and 4, but it's better to say your perfect square number first, okay? And you know what? Check this out. You're not going to like this right now, but watch this. Since you guys said 8 and 4, I want to go with that perfect square number 4 times 8, and we're going to split the root, yeah? And the square root of 4 is the nice, beautiful number 2, no more square root. But you still have the square root of 8 that you have to deal with. And could that be broken down further with multiplication to have a perfect square number? Yes, it could be rewritten as 4 times 2. So you could split that root again. Don't forget about the outside blue 2 that you already took out. And then you could actually do the square root of 4, which is 2. So what you really have is 2 times that green 2 times the square root of 2. So that would be a final answer of 4 square root of 2. Pretty entertaining, right?
So you keep on simplifying until you can.
Keep on simplifying until you can't. Now, is there an advice that I'm going to give you? Yes. The advice is this. Don't go with the first perfect square number on your list. All it takes is a couple of more seconds. Think about this. Oh, yeah, we already know 4 times 8 is 32, but how about 9? 9 times something, but 16 works, right? So if you go from the beginning and take a couple more seconds and say, hey, I could rewrite that as 16 times 2, and you split the root, what's the square root of 16? 4. And what's the square root of 2? It stays. Same, way quicker answer. Always go for the greatest perfect square number when simplifying square roots. Okay? Yep. Alrighty, so like I said, on this section, we're going to be jumping around this page of notes, and we're just going to be focusing in on simplifying square roots of certain values like 50. Normally, if we had more time, I'd be simplifying the square root of 50, x squared, y to the 5th, z to the 8th, right? But we're not going to mess with variables inside square roots right now for the sake of time. What is the square root of 50? How do I rewrite that with multiplication? 25 times 2. And we are splitting the square root to each of those. So 5 square root of 2 is your final answer. Let's take a look at 72 right there. Thank you.
36.
So if we looked at our perfect square number list, the number 4 will work. The number 9 will work. Maybe even 16. All these numbers, all these perfect square numbers will work. As a matter of fact, let me go over here. And remember, we're trying to rewrite 72. Like I said, 4 will work. 9 times 8 will work. But the biggest one, 36, that's the one that's the... Yeah, 36 times 2 is 72. So when you rewrite it, you want to rewrite your perfect square number first, 36 first, times 2 second. That way, when you split the root, you could actually do that first perfect square number, the square root of 36, which is 6, and the square root of 2 stays. Okay? So there is your answer, 6 square root of 2. This could have been done with other different perfect square numbers, but it would take a lot more time, a lot more work. How about the square root of 27?
9 times 3.
9 times 3, okay? So we have a 9 times 3, split the root. What's the final answer?
3 to the...
3 square root of 3. 3 square root of 3. And that's it. Let me just do one right here on the side. What if I said do... How about about 40? Square root of 40. Two times 20. Okay, that's something, but is 2 a perfect square number? No. Is 20 a perfect square number? No. 4 times 10, right? So we could rewrite this as 4 times 10. Now notice I put the perfect square number 4 first and the 10 second, because 10 is not a perfect square number. We could actually do the square root of 4, that's 2. The square root of 10 is simply going to stay the square root of 10. And that's it. That's your final simplified answer. Now, if you're thinking 10 could be broken down to 2 times 5, that's not going to help you, because 2 is not a perfect square and 5 is not a perfect square, right? So that's as far as you could go. That's it, 2 square root of 10. Okay, so again, there's a lot more to this lesson than what we're doing, but we're going to avoid x's right now, variables in there. So with what we've done so far right now, you should be able to answer these guys, and we're going to call this homework, all right? Do number 1, do 3, which are the ones without x's, the 10, the 11, 12, 13, 14. Don't do 15. You know what? 14 might be confusing to some people. I'll do 14 right now with you. But you could do the rest for homework, and you could check your answers on Google Classroom. So what this says right here is the number 3 times the square root of 12. But the square root of 12 is not a perfect square number. So let's rewrite it with multiplication to get a perfect square number. What's it going to be? 4 times 3. Write your perfect square number first. That way when you split it, you'll get your nice answer out in front. The square root of 4 is 2. The square root of 3 stays. Now what about the 3 that's being multiplied out there? You need to bring it down and actually multiply it. So yeah, 3 times 2, that is 6. The square root of 3 is going to stay. There's your final answer. That is pretty easy. Now, this is just, what we've been doing is not even, you're not going to see exact questions like that on the test at all, per se. But they will be part of the quadratic formula when we get to that tomorrow. So we need to know how to do this. We need to know how to simplify it. Even though these aren't actual questions on the test, they are part of the types of questions that we're going to be doing tomorrow. Let's take a look at this next section. But as a matter of fact, we're going to call this homework. What I would like you to do right now is to go to a blank piece of paper and let's review this fact and these practice problems, and then you could come back and do these as practice. So here's the fact. When you apply a square root, when you're solving an equation, you must put a plus or minus symbol on your answer. So here's an equation, and whenever we solve equations, you could do them either mentally or you could do them algebraically, showing your work algebraically. Mentally, this is pretty easy. What number squared will give you 25? 5. But 5 is not the only answer. There's also -5, right? So there's actual 2 answers for this quadratic equation. Now, that shouldn't shock anybody because we've already graphed parabolas, which are quadratic equations, and most of the time, well, not most of the time, but a lot of the times, the parabola crosses the x-axis at 2 locations, which really means that there's 2 answers because the x-intercepts are the answers, they are the roots. Anyway, let's not use mental math. Let's actually let's use algebra to solve this. We want to get x by itself. And whenever we want to get x by itself, we do the inverse operation to get rid of things. For example, if I had an x plus 3, I would subtract 3 and subtract 3. If I had a 2 times x, I would divide by 2, divide by 2. I have a square right here. What's the inverse operation of squaring? A square root. So we're going to apply a square root right there and a square root right there. And that's where this fact comes into play. It says when you apply a square root when solving an equation, you must put a plus or minus symbol on your answer. So yes, the square root and the square eliminate, so that ends up just being x equals, you have to put a plus or minus symbol in front of your answer. The square root of 25 is 5. And that's it. That's your answer. Now that answer, x equals plus or minus 5, is the same thing as x equals positive 5 and x equals -5. It's the same exact thing, but we're not going to do that. We're going to stick with just leaving it plus or minus 5. Yay? Yeah. Okay. Let's move on to one that's a little more fun. This one's definitely more fun. Yeah. So let's not use mental math, right? Let's think, I want to get this x by itself, so I need to get rid of everything around the x. What do I get rid of first? The exponent. How do I get rid of that square? Square root it, and what you do to one side, do to the other side. But again, the fact that we're learning on today's lesson is that when you apply a square root in an equation, you must put a plus or minus in front of your answer. So we know that the square root of 25 is 5, but we're going to put a plus or minus 5 instead of just 5. You have to put a plus or minus in front of your answer. On the left side, what do we have? We have an x minus 1 left over, and of course the square root and the square eliminated, so we don't even have to put parentheses. It's just x minus 1. Now for our final step to get x by itself, I want to do what?
Plus 1.
Plus 1. Add 1. Now, check this out. The plus 1, it's going to be complicated because there's a plus or minus 5. So I recommend doing this. Instead of putting plus 1 down there, let's put this positive 1 up here in front of the plus or minus 5. So this is what it's going to look like. X is all by itself equals, we have the positive 1 and we have a plus or minus 5. So this actually gives you 2 answers. It looks weird, but it actually represents this, positive 1 plus 5, and it also represents positive 1 minus 5. So what are your 2 answers? It's going to be a 6 and a negative 4. Those are your two answers. I mean, you could even double check your answers by plugging them in. 6 right in here. 6 take away 1 is 5. 5 squared is 25. Negative 4 plugged in is negative 4 minus 1 is negative 5. Negative 5 in parentheses squared is also 25.
So would we leave it as the x equals positive 1 and the positive negative 5?
I would,
Or would we
see,
rewrite it?
good question. I would not leave it like that. I would for sure write it as two answers, x equals 6, comma, x equals negative 4. And on the test, I probably will ask you to type it in like that, x equals 6, comma, x equals negative 4. Now, let's say you weren't able to add these two together. Like for some, well, in a couple of minutes, we're going to end up with imaginary values. You won't be able to add those together, so you would leave it like that. But whenever you can easily add 5 and subtract 5 to the number 1, please do it and get your two answers. Yay?
Mm-hmm.
Okay. Let's take a look at, let me delete everything, get more space. Number 3. I want to get x by itself on one side. What should I do? Okay, so now the goal is to get x by itself. Now, if I wanted to get rid of the exponent first, like that, I'd have to do a square root to everything, and I don't really want to deal with the square root of 24 or the square root of negative 8, right? So the easiest thing to do is to get rid of that minus 8 to get the x by itself on one side. So let's get rid of that minus 8 by adding 8. Adding 8. What is 24 plus 8? So what we have left on the left side is 2x squared equaling, what is that, 32? And for my next step, what do I do? Even before square rooting, don't I have a 2 times?
Oh,
Right? So let's get rid of the 2 times by dividing by 2. And that'll cancel out. And I will now have x squared equals what? 16. And now at the very end, get rid of that square root. Get rid of the square by applying a square root. And don't forget that you have to put a plus or minus in front of your answer, in this case 4. So x equals plus or minus 4. So this is the goal of this entire section. What we've been doing the past couple of weeks, we've been factoring to be able to solve quadratic equations. But we don't have to always factor. If you could isolate the x squared and then use a square root, you could solve it this way, right? Anyway, let's move on to this next question. So what's the first step here? Divide by 5. Okay, divide by 5, divide by 5. We now have x plus 7 squared equals 9. Okay, and then what?
Square root.
Square root, square root. We now have x plus 7 equals,
Positive or negative?
that's right, plus or minus 3. Good. And for my final step, what do I do? Subtract 7, subtract 7. Now, this is where, instead of actually subtracting 7, let's just rewrite it with the negative 7 up there. Okay, so what I have is x equaling the negative 7 with a plus or minus 3 right next to it. And that plus or minus 3 means that you're going to add 3 to the negative 7 and also subtract 3 from the negative 7. So let's do both situations. Negative 7 plus 3, negative 7 minus 3. And we'll get our two answers, which are what?
Negative 4.
Negative 4
Negative 10.
and negative 10.
I think I just said 10.
Pretty cool, right?
Yep.
All right, let me expand your minds a little bit. Yeah, check this out, guys. What if I were to take this 45 and make it equal 0 by subtracting 45, and rewriting it? That would kind of look like this. 5 parenthesis x plus 7 squared minus 45 equals 0. But then again, if you have an equal 0, you could put the equal 0 on this side. But then again, if you have an equal 0, you could technically put that as y equals, and guess what? We have a vertex form quadratic equation that produces a parabola, right? And we know a lot of things about this vertex form quadratic equation. It has a vertical stretch of 5, so it's pretty narrow. Not only that, it has the vertex at opposite of this, which is -7. Take the k for what it is, right? H and k. So that has the vertex of -7, -45. Imagine that. -7, -45, way down here somewhere. It's opening up. It's pretty narrow because of the vertical stretch of 5. So it'd be something like that, right? Very narrow, opening up. Guess where it would cross the x-axis? Yeah, -10 and -4. Okay, why am I doing this right now? Not to scare anybody. I just want to try to relate everything that we've been doing, right? We know that graphing parabolas that produce x-intercepts, those x-intercepts are the solutions. So you could choose to look at this equation, rewrite it in vertex form, think about the parabola, and it crosses right there, and those are your solutions, -4 and -10. Anyway, you don't have to do that. There's no question like that on the test. I thought it was interesting to connect the prior knowledge to the current knowledge that we're learning right now. So let's try this guy right here. Step 1, what do I do?
Subtract the 10.
-10.
Yep. Rewrite. We have 3 parentheses x plus 8 squared equals 27.
Divide by 3.
Divide by 3. Rewrite. We have x plus 8 squared equals,
Positive and -9.
oh, that's just 9 right now because we haven't applied a square root yet. But yeah, we're going to now apply a square root, and that's where we get the x plus 8, no more parentheses, no more square, equals, and that's where we get the plus or minus 3. Final step,
-8.
minus 8, but we're going to put that -8 in the front. So we now have x equals the -8 in the front with the plus or minus 3, giving us two answers, -5 and -11. I didn't show my work there. I should have written it -8 plus 3 giving me -5, -8 minus 3 giving me -11. Do you get it?
Yes.
Great. Now, why the heck did I show you how to simplify radicals?
Because it's going to help us in the test.
Because sometimes you're not going to have the square to 9 right here. You might have the square to 20 or the square to 32 or the square to 50 or something like that. So you're going to have to simplify it, break it down. Let's take a look at this one. This will be one of those cases. Step 1 on this.
Subtract 10.
That's right. Subtract 10. Subtract 10. Let's rewrite everything though. 2 parentheses x minus 9 close parentheses squared equals 64. And then you guys just said divide by 2, right? That's really a times 2. Divide by 2, divide by 2. We end up with x minus 9 squared equals 32. And then to get rid of that square, what do I do?
You root it,
Square root it, square root it. I end up with x minus 9 equals,
16 times 2.
okay, so see, here's one of those cases where we need to simplify. We have the square root of 32. It's not a perfect square number, so I'm going to rewrite it with multiplication to get a perfect square number. I could use 4 times 8, but it's a better option to go with what you said, 16 times 2. That way, when you split it, you'll be done. 4 square root of 2 is your answer. So when I say equals, I need to put a plus or minus and this simplified form of the square root of 32. So it's going to be plus or minus 4 square root of 2. All right. What about the -9?
Do we still add it?
We're going to add 9, and of course just rewrite it with the 9 in front. So it's going to be x equals positive 9 plus or minus 4 square root of 2. Now, some people are going to think, oh, I'm going to split it up into 2. You don't have to do that. Why not? Because you can't. What do I mean by you can't? Now, check this out. If I were to say, what's 9 plus 4x? You can't do 9 plus 4x, right? You just leave it, 9 plus 4x. 9 minus 4x, you can't do that. You just leave it. So right here, you can't do, 9 plus 4 square roots of 2. You can't add those together. So you just leave it. So,
So we don't square root the 9 in the end?
no, the 9 is the nice, beautiful number 9. No more. There was never a square root on the 9. So this is just your answer right here. 9 plus or minus 4 square root of 2. Now, at this point, you should be able to go back to this and do questions 1 through 5, but I don't want you to do that yet, okay? But you will be able to do that after class, maybe at home as practice. And on Google Classroom, you'll be able to find and check your answers typed up like this, okay? But right now, I would like you to get a piece of paper and jot down these notes. And the notes that I want you to jot down right now is that the square root of -1 equals I. What? The square root of -1 equals I. What does I mean? It's the imaginary value. It's not real. It's on the back side, but that's like a whole lesson, and we're only going to do a minute part of it. So I would rather you just get a piece of paper and write down the square root of -1 is I. The pieces that we're covering on the notes are just the necessary pieces to do quadratic formula. So, like I said, hopefully we'll have time before Christmas break to come back and do all this extra imaginary values and graphing on a complex plane and complex numbers. But right now, we're just doing the very minimum to be able to apply a quadratic formula. Anyway, if I asked you what's the square root of 9, what's the answer?
3.
Why?
Because 3 times 3 is 9.
Because 3 times 3 is 9, that's right. Now, if I asked you what is the square root of -9, it doesn't work. It's not 3 because 3 times 3 is not -9, and it's not -3 because -3 times -3 is not -9, right? So there is no real answer. This is where you have 3i as an answer, okay? Now, for the sake of understanding this, I'm going to show my work this first couple of times, but you don't have to show your work. You'll just get to the point and just say, oh, the answer is 3i. But this is a work that you're supposed to show. Instead of the square root of -9, you're supposed to rewrite that as -1 times 9, and then you could split the root. And then that way you know that the square root of -1 is I. So we know that this guy right here is I. And then we also know the square root of 9 is 3. And when you have a variable times a number, you just write it together but with the number first, right? If you had x times 3, you're not going to put x3, you're going to put 3x. Right here, I times 3, you're going to put 3i. Yay? Okay, so that's showing your work, but you don't have to show that work, right? But I'm showing that work so it'll be easier if you get something more complicated. So for example, just quick off the top of your head, what's the square root of -25? 5i. What's the square root of -49?
7i.
7i. What's the negative square root of 36?
6i.
6i.
No, I tricked you.
Oh, just
That's just -6, right? The square root of 36 is 6 with the negative sign in front. That's just -6. Okay, remember the square root of a negative, that's where you end up with I. Okay, but anyway, we answered all those without showing any work. Let me delete this as well. I'm sorry, I deleted it. What if I had the square root of -20? So you could show your work and rewrite it as -1 times 20, or you could just remember that this negative sign, when I take it out, that's going to make an I out there, right? So I could rewrite this guy as, let me write it down here, I square root of 20, and now you don't have a negative in there anymore. And now it just goes back to what we've been doing. How do you simplify the square root of 20?
4 and 5.
4 and 5.
4 and 5, so 4 times 5, split it, that's 2 square root of 5, but don't forget about the I that's in the front. So what this really says is I times 2 times the square root of 5. So what we need to do is just rearrange it in the correct order. Whenever you have variables, numbers, and square roots, write the number first, then the variable, and then the square root at the very end. There's your answer, 2i square root of 5. Number first, then the variable, and then the square root at the very end. Okay? Let's try another. How about the square root of -50? All right, showing our work. I square root of 50.
Then you do you break it down and you get negative 25 and then 2.
Uh-huh.
And then just square it.
So we have I.
2i squared.
It'd be 5i to the square root of 2.
5i squared root of 2. Does that make sense? Should we try one more?
Yeah.
Okay. How about you guys tell me, what's the square root of negative 8?
Oh, wait.
You guys want to give me the final answer, or do you want to work through it? Give me the final answer. 2i square root of 2. 2i square root of 2 is the final answer. Let's show how. Again, that negative sign, just take it out and make it an I on the outside. So you have I with the square root of 8. 8's not a perfect square number. You could rewrite it to 4 times 2. Split the root, but don't forget about the I that's out there that's being multiplied. The square root of 4 is 2. You have the I out in front that you need to multiply by, and you also have the square root of 2 at the very end. Just rearrange it. The nice number first, the 2 first, the I second, the square root at the very end. Okay, I think we got this. Now, again, the whole purpose of this entire section, the whole purpose of the test that we're having on Friday is to be able to solve quadratic equations.
It's going to be an I.
Check this out. We might have something like x squared minus 4x minus, let's say, 7. Yeah? Equals 0. That's a quadratic equation. And we've learned different methods on how to solve these quadratic equations. We learned factoring. So because your a value is 1, you might want to try to do this. You guys remember that?
Yeah.
But when you start thinking what times what is negative 7, that it combines together to give you negative 4, you'll realize that it's not factorable, right? So you cannot factor it, so that didn't work. So the question is, does that mean there's no solution? No, there are some answers. And tomorrow we're going to learn how to use the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. And you got to identify your a value is 1, your b value is negative 4, your c value is negative 7. And if you plug it into this formula right here, you'll be able to get your 2 answers. Okay? I know that sounds crazy. It is part of Algebra 1. But it's really not that bad. You just plug in the a value of 1 right there, where the a is at, plug in the a value of 1 right there, plug in the b value of negative 4 right there, b value of negative 4 right there, and the c value of negative 7 right there. And if you do the math correctly, you'll get to the 2 answers, right? Now, sometimes when you're doing this inside part of the square root, you might end up with a nice, beautiful answer like 36, right? And then when you do the square root of 36, you're going to end up with a number plus or minus 6. Which you'll be able to do, right? But sometimes inside here, you end up with 20, and you got to simplify the square to 20, right? Sometimes you might end up with a negative number, and that's when the imaginaries come out. So today's long lesson, but that I just picked and chose the portion of the lesson that we did, was just to be able to understand how to simplify this square root on the quadratic formula tomorrow. Because once we learn the quadratic formula, we'll be able to solve any quadratic equation, whether it's factorable or not, using the quadratic formula. Okay? So that's what today's lesson was about, to just know how to simplify square roots and also how to deal with negative numbers in there that become imaginary when you take the square root of a negative. Tomorrow we'll continue, or we'll actually review or teach quadratic formula.